NASA's Voyager 2 spacecraft, which is exploring the interstellar space beyond our solar system, recently encountered a communication breakdown with mission control. For months, the spacecraft was unable to send any data back or receive any commands from Earth. But then, in a surprising turn of events, it sent a signal to Earth confirming that it is still alive and well. How did this happen, and what does it mean for the future of this historic mission? In this video, I will explain what caused the loss of contact, how NASA restored communication, and why Voyager 2 is so important for our understanding of the universe. What happened? Voyager 2 is one of the two twin spacecraft that were launched in 1977 to explore the outer planets of our solar system and beyond. It is currently about 12.4 billion miles away from Earth, or more than 130 times farther than the distance between the Earth and the Sun. To communicate with it, NASA uses a network of giant radio antennas called the Deep Space Network, or DSN, which can send and receive signals from distant spacecraft. However, in July of this year, something went wrong. NASA sent a series of planned commands to Voyager 2, but they inadvertently caused the spacecraft's antenna to rotate 2 degrees away from Earth. This was enough to cut off its links to the DSN, leaving it unable to send any data back or receive any commands from Earth. NASA realized that they had made a mistake, but they couldn't do anything about it until the next scheduled reorientation maneuver, which was set for October 15. Until then, they had to wait and hope that Voyager 2 would stick to its planned trajectory and not encounter any problems. This was not the first time that NASA had lost contact with Voyager 2. In fact, in January 2020, the spacecraft went silent for several days due to a glitch in its power system. NASA was able to fix the problem by sending a command that reset the system and restored communication. But this time, the situation was different. NASA couldn't send any commands to Voyager 2 until it pointed its antenna back at Earth, and they didn't know when that would happen. So what caused this communication breakdown recently? According to NASA, it was the result of a complex sequence of commands that were meant to test some of Voyager 2's instruments and systems. These commands included turning on a heater for one of the instruments, switching off another instrument that was not working properly, and changing the data rate for transmitting information back to Earth. These commands were supposed to be executed in a specific order and timing, but somehow they got mixed up and resulted in rotating the antenna away from Earth. NASA said that this was a rare and unfortunate event that was not likely to happen again. They also said that they were reviewing their procedures and protocols to prevent such errors in the future. Then on August 1, something unexpected happened. The DSN picked up a faint signal from Voyager 2, indicating that it was still broadcasting its heartbeat or carrier signal. This signal is like a basic form of communication that tells NASA that the spacecraft is still functioning and ready to receive commands. However, it doesn't contain any scientific data or information about the spacecraft's status. NASA was thrilled to hear from Voyager 2 again, but they still had a challenge ahead of them. They had to try to send a command to Voyager 2 to tell it to point its antenna back at Earth. If that didn't work, they would have to wait until October for the automatic reset. Fortunately, after several attempts, they managed to send a successful command and restore full communication with Voyager 2 on August 3. Why is it so important to keep in touch with Voyager 2? Well, because it is one of the most valuable sources of information about the interstellar space that lies beyond our solar system. Voyager 2 is one of only 2 spacecraft that have ever reached this region of space, where the influence of our Sun is very weak and the influence of other stars is stronger. The other spacecraft is Voyager 1, which entered interstellar space in 2012 and is currently about 15 billion miles away from Earth. By communicating with Voyager 2, NASA can receive data from its instruments that measure the temperature, pressure, density, and speed of the interstellar plasma or gas that surrounds it. This data can help us understand how our solar system was formed and how it interacts with the rest of the galaxy. It can also help us detect any changes or anomalies in the interstellar environment that might affect our planet or other spacecraft in the future. For example, in 2019, Voyager 2 detected a sudden increase in the density of the interstellar plasma as it crossed a boundary called the heliopause, which marks the end of the solar wind and the beginning of the interstellar wind. This increase was also observed by Voyager 1 6 years earlier but at a different location. This suggests that there might be some variations or fluctuations in the interstellar plasma that are not fully understood yet. Another example is that Voyager 2 detected a different orientation of the interstellar magnetic field than Voyager 1. This could mean that there are some differences in the structure and shape of the heliosphere, which is the bubble of magnetic fields and particles that surrounds our solar system and protects it from harmful cosmic rays. These are just some of the fascinating discoveries that Voyager 2 has made and continues to make as it travels through interstellar space. By keeping in contact with it, NASA can learn more about this mysterious and unexplored region of space and gain new insights into our cosmic origins and destiny. The golden records. Both Voyager 1 and Voyager 2 have made incredible discoveries and achievements in their long journey through space. They have visited all 4 giant planets of our solar system, Jupiter, Saturn, Uranus, and Neptune, and revealed many secrets about their atmospheres, rings, moons, and magnetic fields. They have also observed phenomena such as volcanic eruptions on Jupiter's moon Io, the mysterious hexagon on Saturn's north pole, the tilted axis of Uranus, and the geysers on Neptune's moon Triton. But perhaps their most remarkable achievement is reaching interstellar space and becoming the first human-made objects to do so. Interstellar space is the space between stars where no spacecraft has ever gone before. It is filled with cosmic rays, dust particles, and magnetic fields that are different from those in our solar system. By studying this environment, Voyager 1 and Voyager 2 can help us understand how our solar system was formed and how it interacts with the rest of the galaxy. Voyager 1 and Voyager 2 are also carrying something very special, golden records that contain sounds and images of Earth as a message for any potential alien civilization that might encounter them in the future. The records include greetings in 55 languages, music from different cultures, natural sounds such as birds and waves, and pictures of people, animals, and landscapes. The records are designed to last for billions of years and represent humanity's story and diversity. The idea of sending these records was proposed by Carl Sagan, a famous astronomer and science communicator who was also involved in the Voyager missions. He wanted to create a time capsule that would capture the essence of life on Earth and share it with any intelligent beings that might exist elsewhere in the universe. He also wanted to inspire people on Earth to appreciate their planet and their place in the cosmos. The records contain a variety of sounds and images that reflect the diversity and beauty of Earth and its inhabitants. Some of the sounds include a baby's cry, a mother's kiss, a train whistle, a thunderstorm, a heartbeat, laughter, music from Bach, Beethoven, Chuck Berry, Blind Willie Johnson, Louis Armstrong, Mozart, Stravinsky, and many others. Some of the images include a sunset, a sunrise, a mountain range, an ocean wave, a flower, a tree, an elephant, a whale, a bird, a human face, a family portrait, a map of Earth, a diagram of DNA, a painting by Van Gogh, and many others. The records also contain instructions on how to play them using a phonograph needle and an electric motor. They also include mathematical symbols and diagrams that explain how to locate Earth in relation to several pulsars or rapidly spinning stars that emit radio waves. These pulsars act like cosmic lighthouses that can help navigate through space. These records are attached to the exterior of each spacecraft, along with a plaque that shows an image of a man and a woman standing next to an outline of the spacecraft. The plaque also shows the relative position of our Sun to 14 pulsars, whose periods are given. The plaque is meant to provide information about who sent the spacecraft and where they came from. The records are not expected to be found by anyone anytime soon. They will take tens of thousands of years to reach another star system, and even if they do encounter another civilization, there is no guarantee that they will be able to understand or appreciate them. But they are still a testament to our curiosity and creativity as a species. They are also a reminder that we are not alone in this vast and beautiful universe.